8.2 volume. It says here, first of all, to recap the area of a circle, pages 124 and 125. So let's just have a quick discussion about circles. If we've got a circle, we know that the radius is r. Then the circumference, which is the perimeter, which is the way all around the outside of a circle. The circumference is going to equal 2 pi r or pi d. And the area of the circle, which is the amount of space it contains, is pi r squared, and that's pi multiplied by r squared. So you would square the r first of all and then multiply it by pi. So if the radius was 3, area would be pi times 3 squared, which is pi times 9, which is 28.3 squared centimeters. The circumference for this circle would be 2 times pi times 3, which is 6 pi, which is 18.8 centimeters. So that's just a wee quick recap on circles. Prisms then. A prism is a solid which has the same cross section along its length. So this rectangular prism, if we were to make slices along it, so along this line here, what we would see is that you would have lots of little rectangles. You could do slices through it lengthwise as well, and you would have long, thin rectangles, or in this case as well, you could do slices horizontally and you would have long rectangles again. Now in a circular prism, now the special name for that is a cylinder, we'd need to take cuts parallel to the two circles. So if we were making cuts horizontally, then every time we look at the shape that we've cut, you would have a circle. If we were to cut vertically, we would have, I'd say you'd have different rectangles of differing sizes. So a prism has the same cross section, so we'd have to do it horizontally, in this case for the circular prism. And this triangular prism, again, we'd have to cut along the length so that each shape would be this triangle. The trapezoidal prism, again, we'd have to make cuts along the top rectangle so that each face would look exactly the same. Now, to work out the volume of a prism, we multiply the cross-sectional area by the length of the shape. So in these examples, if we look at this one first of all, so volume is the cross-sectional area times by the length. The cross-section is a triangle, and to work that out, it's going to be a half times the base times the perpendicular height, which is a half times 3 times 5, which is 7.5 squared centimeters. Then we need to multiply it by its length, and we can see that the prism is 10 centimeters long, so we'd multiply the cross-sectional area by 10, and that gives us 75, and it's cubic centimeters because it's volume. 2, if we're looking at shape 2, it's a trapezium. So again, volume is cross-sectional area times length. Now for the cross-sectional area, it's going to be a half of A plus B times H, which is a half of 3.5 plus 1.5, so those are the two parallel sides, times by the perpendicular distance between them. So the base is 3.5, and the top, we're maybe not initially sure exactly what length it is, but because this is a prism, this trapezium will be the same shape throughout the prism, so the shape at the back of the prism would also be a trapezium. So then this is 1.5, so the top is 1.5. and then the perpendicular distance is 2. So the cross-sectional area is 3.5 plus 1.5 is 5. 5 times 2 is 10, and a half of 10 is 5. And then we need to multiply it by its length, which is 9. So 5 nines are 45 cubic centimetres. The next example then, we've got a cylinder, and before that we can see that it says in the notes the cylinder is the most common prism and its volume is pi r squared h. So that's the formula. Now it's coming from the cross-sectional area times the height or the length, because the cross-sectional area is a circle, which is pi r squared, and then the length we normally just call h for a cylinder. So it's made up of the area of a circle times by the length of it. So here we've got volume is pi r squared h, which is pi times 6 squared, so the radius is 6, times by the length or the height of the cylinder, which is 12. That's going to be pi times 36 times 12, which is 1357.17 cubic centimetres. Next example, find the volume of the shape below. So again, we can see this is a prism. It kind of looks like a loaf of bread. So the volume of a prism is cross-sectional area times height, and we know that the height is 32. We can see that here, so we need to figure out what the cross-sectional area is. So what we have for the cross-sectional area, it's going to be a composite shape. It's made up of a rectangle and then a semicircle. So let's call that 1 and 2. So area of 1, which is a rectangle, is length times breadth, so 23 times 17, which is 391 squared centimetres. Area 2, so it's a semicircle, which is half of a circle. So the area of a circle is pi r squared. So a semicircle is going to be pi r squared divided by 2, which is going to be pi multiplied by the radius. So the base length of the rectangle is 23. The base of the semicircle then is also going to be 23, and the base of this semicircle is its diameter. So if the diameter is 23, the radius, which is half of that, is going to be 11.5. So the area is pi times 11.5 squared, and then we'll divide that by 2. So 11.5 squared is 132.25 divided by 2. And if I put all of that into my calculator, I get an answer of 207.74. So that's the area of the cross section. I know the length of the prism. So the volume then is going to be, so that's 207.74 multiplied by 32. And putting that into my calculator, you get an answer of 6,647.61, and it's cubic centimetres. The next example, we've got a cuboid has a volume of 40, a length of 5 and a width of 2. Work out the height. So quite often whenever we're given wordy questions, a picture can be quite useful. So I'm going to draw my cuboid. So the volume is 40, the length is 5, the width is 2, and the height is what we're looking for, so let's call that h. Now we know in a cuboid the volume is the length times the breadth times the height. The volume we're given is 40, the length is 5, the breadth is 2, and the height is h. So 40 is equal to 10 times h, which is 10h, and if I divide by 10, I get that 4 is equal to h. So the height of the cuboid is going to be 4 centimeters. And then the next example, the diagram shows a cylinder. The radius of the cylinder is r. The length of the cylinder is 0.1 meter. We can see that in the diagram that's been translated 10 centimeters because all the other units are in centimeters, so the 0.1 meters should be changed into 10 centimeters. If the volume is 140 cubic centimeters, again centimeters, then we need to find r. So the formula for the volume of a cylinder is pi r squared h. We're told the volume is 140, and that's pi times r squared times 10. So we're all in centimeters here. So if I divide by 10, first of all, that will get rid of the 10 on the right, and I get 14 equals pi times r squared. Then I can divide by pi to get 4.456 is equal to r squared. And then if I take the square root of both sides, so the square root of 4.456 is going to equal r, which equals 2.11 centimeters. So the radius is 2.11.